Okay, sorry about that. My previous recording was over, so I had to start a new one. So let's pick up where we left off. This was a piecewise function, and it says find the limit as x approaches 2. The first part of the function says your f of x is equal to 1, where x cannot equal 2. So in other words, you have a horizontal line going through y equals 1, and you're going to have an open circle at x equals 2 because you don't want the line or your function to go through that value. It's not inclusive. Our next part, if you think about it, says f of x equals 0 when x is equal to 2. So this is basically a coordinate. It's saying when x equals 2, then your y value will equal 0. So that is basically a shaded circle or a function at that point. Now we're going to approach the limit as x approaches 2. However, before we take the entire or overall limit, we have to take it from we have to approach it from the left and approach it from the right. So once again, if you want to go ahead and place your wall or your vertical line right here at x equals 2. And if you think about it, if we're going to approach from the left-hand side, that means it's this part of the graph. So if we approach from the left-hand side, my y value is at 1. So my limit from the left-hand side is 1. And if I approach the wall from the right-hand side, my y value is still 1. So both the left-hand and the right-hand limits do exist, and they're both the same, which is 1. So my overall limit is 1. Please keep in mind that even though my point is not inclusive, I can still have a limit, and vice versa. Like this one, like my shaded in circle. I have a function there. My function does exist because of the shaded in circle. However, I don't have anything approaching it from the left or from the right, so it wouldn't exist. So please make sure you know the difference between that. So we have the limit is 1 since f of x is equal to 1 from the left and from the right as x approaches 2. And I put a little note there that we said that the value of f of 2 is immaterial. That means we didn't need this part right here. That was useless information. Okay, so let's continue. Actually, we'll go back to the tabular method. Now it says find the limit of this function. Well, it doesn't say that yet, but I have a function that is x cubed minus 1 over x minus 1 as x is not equal to 1. And if you remember, the reason why it cannot be equal to 1 is because if you were to plug in 1 into the function, you would get division by 0, which is undefined. So sometimes when you have functions like these, your best bet is to factor as much as you can. And in this case, you are going to be able to factor the numerator, and you have an x minus 1 times x squared plus x plus 1 all over x minus 1. Now, your x minus 1 cancel out, but please keep in mind that they are still a point of discontinuity. However, in this case, we would consider them as a removable discontinuity because obviously we're removing them from the function since they cancel out. So you're still going to have a point, and the following is a picture or a representation of what the leftover part is, because if you cancel x minus 1 out, you're left with x squared plus x plus 1, which is simply a quadratic function with a parabola opening upwards. And if you were to plug in the value of 1, since it's our point of discontinuity, you get 1 squared plus 1 plus 1, which gives you a 3. So again, make sure you know all of those characteristics. Now what I'm going to do is we're going to approach that function to 1. And we're going to use the tabular method. So if we approach the function to 1 by using the tabular method, that means you're going to have a set of values approaching, or a set of values from the left and from the right of 1. Remember, usually with tabular method, I will provide you the values. All you have to do from here is to do what? To get your y values. All right, you're going to substitute them back in. You may be wondering, well, which one do we use? Obviously, I would use this one because you're just going to be left with x squared plus x plus 1, which is less to type in and less mistakes one can make. However, you can still use this one but most of y'all don't seem to really be able to type in, especially when it comes to fractions, and then you mess up whenever you type it in. So make sure you pick the one that's easiest to type in. Okay, so if we approach each of these, or we substitute each of these values, we get the following on the left-hand side, and then we get the following on the right-hand side. So if you pay close attention, if we approach it from the left-hand side, the y values apparently get closer and closer to 3. And the right-hand side, your y values will get closer and closer to 3 as well. So overall, what can we say about the limit of this function as x approaches 1? Well, your best bet is that it's going to approach 3 to begin with. So we say therefore, and you don't need to have these 3 dots. These 3 dots mean therefore. That was just me ending the problem. I say that the limit of my function as x approaches 1 is indeed 3. Okay, and so we've talked about graph methods, tabular methods, and now we're going to go ahead. I think I've briefly discussed about plugging them in or direct substitution, and you've seen a format of this type before. I may not have necessarily used these letters, but you've seen it, and that's the next type of limit, is by actually direct substitution. So if you have a limit of x squared plus 3 as x approaches 2, go ahead and substitute the x or the 2 in for x, so you get 2 squared, which is 4 plus 3, which gives you 7. Now remember that I said I probably sound like I'm contradicting myself, where I tell you that we're only concerned with what's going on around the value. So you're probably asking yourself, why are we plugging in if we're not concerned with what's going on at that point? Well, your best bet is to or your best guess is whatever's happening at that point is most likely what's happening around that point. So as you can see from the tabular method, what was happening around, we deduced that that's most likely what's going to happen at the point. So now it's like we're going backwards. Well, whatever's happening at that point must be what's happening around that point. So that it kind of works that way also. All right, so let's go ahead and use or do this example. It says evaluate the function at several points near x equals 0 and use the results to find the limit. So you have the limit of f of x as x approaches 0, and you have your function right here. Again, tabular method, very simple. The only difficult part about tabular method is some of you all tend to kind of misplace your decimal point, or add a little bit more zeros than usual, or not add enough zeros. So you need to be careful that you're doing the right, or you're punching in the right value. Now in this case, you need to be careful because take a look, the square root is underneath the x plus 1. Not the entire thing, it's only underneath the x plus 1. So whenever, for example, if we were to plug in negative 0.01, we would say negative 0.01 here, then square root, negative 0.01 plus 1, then you're going to press that right hand arrow so that you can get out of the square root. If you don't press that right hand arrow, you're not going to get out of the square root. It's going to have it all underneath one square root, which will give you a wrong answer. So you need to make sure that you do that correctly. Okay, so if you plug each of those values in, you get the following. And we're going to skip 0 because if you were to plug in 0 in, you get 0 plus 1, which is 1. The square root of 1 is 1, and 1 minus 1 is 0. So it gives you division by 0, which is undefined. And then if we plug in the right-hand values, we get the following. So if you estimate, or if you look at what's going on in the table, then you see that from the left, you're approaching 2. From the right, you're also approaching 2. Therefore, you can say that the limit of your function as x approaches 0 is most likely 2 as well. Now we're going to go ahead and practice a little bit more. So I have this following graph right here, the following graph, and we're going to just look at it right quick. Looking at a graph and taking the limit of a certain value is probably the easiest thing you can do. So first of all, let's approach this function as if we're approaching the value negative 2. So again, if you want to place your vertical line or your wall right here at negative 2, do that. Okay, so if you approach it, but remember that before we can even say what the limit is as x approaches -2, we have to approach from the left and from the right. So let's approach it from the left-hand side. If you realize that's the left-hand side of this wall, or the imaginary wall, even though you don't see it, is this part right here. So if we approach from the left, my y value is 2. And if we approach from the right, I'll start right here, my y value is still 2. Therefore, the limit of this function as x approaches -2 is 2. Why is that? Because my right-hand limit and my left-hand limit are the same, and they are 2. Okay, let's approach this exact same, let's use this exact same function and approach it, approach 0. That's what we're going to do. Okay, so if you pay close attention, we're approaching 0, which is this vertical line right here. First of all, does a function exist at x equals 0? And what is the value? Well, yes, f of 0 does exist, and f of 0 is actually 3. So remember, a function is basically if there's a shaded or an unshaded circle. If you didn't have one, then of course it wouldn't exist. If you did have one and it's shaded, then it would exist at that point. So in other words, yes, it does exist, and it exists at f of 0 equals 3. Now, since we're approaching, let's go ahead and take the limit. So remember, the limit of this function as x approaches 0. Before we can do that, we have to approach it from the left, and we also have to approach it from the right. So if we approach from the left, that's this function right here. So my wall is right here. If we approach from the left, we continue from the left, and we get our y value to be -1. If we approach from the right, it's this part right here, so we continue, and my y value is 3. -1 and 3 are not the same value, therefore my overall limit of this function as x approaches 0 does not exist. Okay, now if we quickly approach 1 with the same function, before we can do that, we got to approach from the left and from the right. So if we approach from the left, my y value is indeed 1. If I approach from the right, my y value is 1. They're both the same, so my limit is indeed 1. However, my function exists where? At -1. So your function can exist somewhere differently from where your limit happens or exists also. So make sure you know the difference between that. Okay, this wraps up the lesson. I'll go ahead and let you have the rest of the time to either go back and look at the videos and finish your notes, or you can just go ahead and I have my cabinet open. You're more than welcome to go ahead and start any of your presentation grades for those juniors that need to do them. I don't remember what chapter we're on. I think it's all the way in chapter 13 for limits, first section, introduction to limits. But if you're not sure, or if you're not too comfortable with doing limits just yet, you're more than welcome to do something from the previous section, which was, I believe, 3.3 and 3.4 with logarithms. So again, have a good day, and I hope to see you all on Tuesday. Thank you.